Hello everyone, the topic which we'll be covering today is the logical and the physical extract in Tableau. Basically, the concept of logical and physical extract in Tableau is being introduced in the version 2020.2. So, in version 2020.2 and later, we will see the concept of logical and physical extract being used. So, before jumping directly to the logical and physical extract part, we'll first understand few basic topics which will help us to understand the concept in a better way. So these are the list of topic which we'll be talking about. First, we'll cover the Tableau data model. Then in Tableau data model, we have two layers, which is the logical layer in which relationship is used. Then we'll talk about physical layer in which joins and unions are used. Then we'll understand the characteristics of relationship and join, like what is the advantages, disadvantage of using them. Then in the end, we'll talk about the logical table extract and the physical table extract. So in extract, we have it can be done using either by logical or by physical, so you'll understand the which one to be used in what purpose. What is Tableau data model? So Tableau data model is nothing but the activities, like whatever activities we perform in the Tableau data source page create the structure of a data model. So basically every data source that we create in Tableau has a data model. The table that we add to the canvas in the data source page create the structure of the data model. The data model can be simple or can be complex also. If we just added a single table, it is a simple data model. If we added multiple tables or views in it with the join condition, union condition, or relationship applied to it, that it can be a bit complex. When we talk about Tableau data model, it has two layers in it. The first is the logical layer and the second is the physical layer. As you can see in the diagram, in the top I have the logical layer and in the down there is the physical layer. So when we drag a table or a view to the canvas, by default it goes to the first layer, which is the logical layer. In the logical layer, the tables or views are linked to each other by relationship. Now in this diagram, the first one is the logical layer. In the logical layer, we have table A and table B. Table A and table B are linked to each other by a relationship. Now in the down, we have physical layer. Each logical table has a physical layer within it. If you see in this example, logical table A is joined with multiple other table and the join condition has happened in the physical layer, not in the logical layer. Similarly, for logical table B also there is a physical layer, but table B is not joined with any other table. So in the physical layer, only the table B is present. So this is the logical layer and the physical layer. In the logical layer, the tables are joined by relationship, and if you want to perform any join condition or union, then it is done in the physical layer. So let's understand this particular concept in Tableau itself. So I have Tableau public opened up. Now this is the data source page of Tableau. The left hand side I have the sheet, the order, people and return sheet. I have connected to sample superstore dataset. Now the canvas is blank as I don't have anything in it. Now this is the place where we build our Tableau data model. Now the data model, as I have said, can be simple or complex based on the requirement. If we drag only few tables with no much condition, then it will be a simple data model. If we drag multiple table with with the multiple join condition union in it, then it can be a bit complex also. So as I said, in the Tableau data model, the data model is divided into the two layers, the logical layer and the physical layer. So let's understand that particular portion. So let's track the first sheet, which is the order sheet. So now whatever we drag table or sheet in the canvas, it first goes to the default by default layer, which is nothing but the logical layer. Now this particular Tableau data model has order sheet in it with the below showing the data, and this is the logical layer. Now what happens in the logical layer if I drag one more sheet or table? So let's take people sheet also in the canvas. So now we will see that the order and the people sheet are linked to each other by a common column, uh, which is region, and which is done by Tableau by default. And uh, we can edit it by our requirement, like whatever column we want to choose, we want to add it, and both the sheets, the order and the people, will be linked to each other. Now this line is nothing but the relationship. The order and the people sheet are linked to each other by a common column, with a relationship, so they are not joined to each other, there is no join condition applied, but they are just linked to each other. Now, about relationship and the difference between relationship and join, I'll talk about that in a little in the further slide, but we will just understand now the concept of logical and the physical layer. So this is the logical layer where two sheets or table are linked to each other by a common column, they are not joined. Now, how can we perform join condition? So for performing join condition, we have to go to the physical layer. Now, if I want to perform a join condition in this particular order sheet, then I have to click on here, or I can double click also, I can open it. Now I will go to the physical layer of the order table. So this is the place where I can perform the join condition with this particular order sheet. I can drag the return sheet here. Now the order and the return will be joined to each other by a join condition. So I can select the join condition from here, either it will be a left inner join or whatever according to our requirement. So again we can come out of the join condition, this physical layer, by crossing this, then I will be in the logical layer again. So if you see, the order sheet has this Venn diagram, so it indicates that it has a join condition applied in the physical layer itself, but we see in the people we have not done anything in the logical layer, so nothing is there. But in the logical layer I will have this particular people sheet present. If I go there, you can see I have the people sheet present and my data will be available here, and I can perform join condition if I want. If I don't want, then I can leave as it is. So this is the logical layer where it will be joined using a relationship. And if you want to perform any kind of join condition or union condition, then we can go inside that particular logical layer of that particular table and perform our join condition. So as explained in the Tableau data model diagram and Tableau desktop, logical layer is the default that we first see in the data source page canvas is the logical layer of the data source. We can combine data in the logical layer by using relationship instead of join condition. We can also think of this particular layer as a relationship canvas because we use relationship instead of join, and we can combine data from multiple tables. Each table that we drag to the canvas in the logical layer must have a relationship to another table, means they must be linked to a particular column. A common column should be present. We do not have to specify join type for relationship. During the analysis, Tableau automatically select the appropriate join type based on the uh, based on the field and the context for analysis in the worksheet. But we, if we want, we can also change the column according to the requirement. Now coming to the physical layer, so physical layer of the data model is where we combine the data using join conditions and unions, and this particular layer was not there previously in the Tableau version. So after 2020.2 version, this particular layer is being introduced, and each logical table contain one or more physical table. So whatever table we drag in the logical layer, that particular table will have a physical layer also. We have already seen the logical layer and the physical layer. We have seen that in the logical layer relationship is used, and in the physical layer we use join condition. So let's understand the relationship first point by point. So relationship require you to select a matching field between two logical tables. It does not require you to select join type. So when I have two table in the logical layer, logical table A and logical table B, both are linked to each other by a common column, and they are just linked by using a common column, that is relationship, and doesn't require you to select any join condition. Make all the rows and column data from related table be available in the data source. It maintain each table level detail in the data source during the analysis. So when I have two table A and table B, so individual data of table A and table B will be present and is stored, and the table level of detail will be present in it. Now it create independent domain at multiple level of detail. Table aren't merged together in the data source. During analysis, create appropriate join automatically based on the field in use. So when I have two table A and table B, so individual data will be available for table A and table B. The data will not be merged together as a single data as it happens in the join condition. Now it do not duplicate aggregate values when performance options are set to many. It keep the unmatched measure values. So what does this mean is as the data of table A and table B are individually stored and present, so it even if there is a value which is not matching, it will keep that value also and it doesn't remove any value. Now let's understand the join part. When we talk about join the symbol is the Venn diagram icon and we select the join or perform join condition in the physical layer itself. We have to select the join type like inner join, left join, right join according to our requirement. Joined physical table are merged into a single table with a fixed combination of data. So when a table A and table B are joined together by a inner join or a left join based on the requirement, so the data of table A and table B will be merged with that join condition and it will be a combination of data. Unlike in relationship where the table A data and table B data will be individually present and they will not be merged together. So as in join, the data of table A and table B are merged together and present as a combination of data. So it may happen that if there is a value which is not matching in one of the table may be dropped. That value may be dropped out and may the duplicate values will be removed from it. So may duplicate aggregation values when fields are at different level of detail. Now it supports scenarios that require a single table of data such as extract, filter and aggregation. So this is the difference between relationship and join. Now let us understand clearly the relationship and join in the Tableau public itself. So let's understand the relationship and join in Tableau public. So as you can see, this is a Tableau public opened up and I don't have anything in the canvas. So let's drag the orders sheet in the canvas so it will be dropped in the logical layer. So as you can see in the logical layer I have the order sheet. Now let's take one more sheet which is the people. So we will see that the order and the people will be linked to each other in the logical layer by a common column which is a region which is done by Tableau by default, and if you want to change it we can click here and choose the column which is required from our end. Now what is happening to the two sheets and when they are linked with a relationship. So when I click on the order sheet I can see in the down I will be able to see all the column and the details or the data of the order sheet only. When I click again on people I'll be able to see the column and data of the people sheet. So in logical layer, they are linked with a common column by relationship and both the individual sheets data are individually stored or individually present in it. They are not merged together like what's happening in the join. Now let's understand what happened in the join condition. Now if I go to the physical layer of the order sheet and I will take the return and do a inner join in it. So now we will see that the order sheet and the return sheet are joined together by an inner condition, and in the down the data which is present here is a combination of order and the return sheet. If you see, these are the columns of the order sheet and these two is the column of the return sheet. So this is a combination of data, and when we combine data it might happen that there are some values which is present in one table and not in other table. So in that scenario that particular value is get dropped. But in case of relationship, individual sheet data will be individually present and hence there will be no removal of data. If even if there is unmatched value that will be present, even if there is duplicate values that will also be present. So that is the main difference between relationship and join. So we have already gone through the logical table and the physical physical table explanation. In the logical layer we use relationship, in the physical layer we use join condition. For every logical layer there will be a physical layer which will be present for it. Now coming to the extract part, when we click on extract or we want to do an extract, Tableau will give us an option to create our extract either by logical table or by physical table. So let's understand individually the logical table extract and the physical table extract. We can choose to have Tableau store the data in our extract using one of the two structure schemas, that is the logical table, which is present in a denormalized schema, and the physical table which is in the normalized schema. So denormalization means that the technique of combining the data into a single table to make the data retrieval faster. So let's talk about the logical table first, where it is stored the data using one extract table for each logical table in the data source. Physical table that define a logical table are merged and stored with that logical table. So let's understand this particular statement in the below example. Suppose if I have a data source which was made up of single logical table which has a physical layer. As I have only a single logical table, the data will be stored in that single table itself. Suppose if I have a data source with three logical table, and suppose each containing multiple physical table within it. So as I have three logical table, the data will be stored individually into three tables, each for one logical table. So how many logical tables will we will have? The data will be stored on that particular tables. So basically we can go with the logical table extract option when we want to limit the amount of data in our extract by adding additional extract properties like extract filter, aggregation, top and filter. So right hand side I have the screenshot where I have the logical table and the physical table. Right now I have logical table selected, and as you can see in the below I have an option to add the columns where in I can add the columns and I can minimize the extract if required. So this option is only available in the logical table. If I choose the physical table, this particular option to add the columns and to reduce the extract is not available. So we can also use the logical table option when your data uses the pass through function. Now this is the default structure of Tableau uses to store the data, extract data. Now one thing important here is like if you use this option when your extract contain joins, the joins are applied when the extract is created. Now when I have clicked for logical table extract, and in my data model I have join condition table which has joins, so the joins will be performed at the same time and then the extract will be created. So this might be time consuming for the extract which has huge amount of data. About the physical table extract, so physical table extract is present in a normalized schema. So normalization is the technique of dividing the data into multiple table to reduce the data redundancy and inconsistency to achieve the data integrity. Now the tables present in the physical table extract store the data using one extract table for each physical table in the data source. The data, so basically the data is stored in each physical table. How many physical table I have, in that many tables the data will be stored. Now in the physical table extract, the joins are performed at the query time. So basically the joins are not performed when we create an extract. So when we are creating extract in the by selecting the physical table, each table data will be stored individually in the physical table. Joins will not be performed while creating the extract. Join condition will be performed at the query time or in the visualization when we do our task. So because of this option can improve the performance because it will take less time to create our extract, and the size of the extract will also will be reduced. Now there are some condition to use the physical table option. So to store your extract using the physical table option, the data in the extract must meet the below conditions. So the conditions are all join between the physical table are equality join. The data type of the column used for relationship or joins are identical. No pass-through function should be used. No incremental refresh can be configured. No extract filter can be configured. No top n or sampling configured. So these cannot be configured because when we select for physical table extract, these particular options are not present, they are disabled. These are only present when we choose for logical table. Important thing we have to note is that both the logical table and the physical table option only affect how the data in your extract is stored. Either it is stored in a combined form or it is stored in an individual form. So this option does not affect how tables in your extract are displayed on the data source page.